In this sequencing series, we are asked again to evaluate the series. Again, we're dealing with what's called summation notation. Remember, sigma, this symbol, this Greek symbol, means sum or add. And in this case, in a previous example we would evaluate, or we expanded this sequence and then added up all the terms. Well, that's okay if it's kind of a short sequence, but if we do that in this case, we're going to have to crank out 40 terms and then add those all up. And that could be kind of long and tedious, to say the least. Fortunately, there is another equation that we can use when we're doing that to be able to do this. And here's the equation that kind of simplifies this process. Whenever it's set up like this, where we're just substituting in a number for k, and we're going up to a specific number here, and the way it looks is this. We write it as a summation notation, or sigma, when k is equal 1 to n of k. Then what we do, we can use this shortcut notation, or it's not really a shortcut, but I call it a shortcut because it's shorter than cranking out 40 terms. We've actually got this other formula we can use that says if we take what n is and multiply it times itself plus 1 and then divide that by 2, that will actually give us the total sum. So now let's apply this formula to help us out here. In this case, we know that n is going to be equal to 40, and we know that k is going to start at 1. So if we use that for this, k is equal to 1 to 40, and we're just doing k. We're substituting in what k is each time. Remember, we start with 1, and then we increment up each time. So let me just crank out a little bit of this first, and then I'll show you what I'm talking about. Like, for example, the first term will be 1, plus we'd crank k up to 2 then. The next term will be 2. The next term will be 3, and so forth. And so what we want to do is we want to be able to find the sum of all those, and we're going to use this kind of shortcut formula to help us out with that. So in this case, n is going to be 40. So we're going to use that, and we know that the ultimate sum is going to be 40 times 40 plus 1 divided by 2. That's much shorter than having to type every one or do every one of those terms and then add them all up. So if I simplify that, that's going to be 40 times 41 divided by 2. Well, I could punch that into a calculator real quick, and that would be easy. Let me just do it over here real quick. I have 41, and here's a little math trick. If I have a number that ends in a 0, I can offset it this way and multiply. Just bring the 0 straight down. 4 times 1 is going to be 4. 4 times 4 is 16. So that's going to tell me that 41 times 40 is going to be 1,640 divided by 2. Now, to find the answer to that, we need to do a long lost practice called long division. So I'm going to divide 2 into 1,640. 2 won't go into 1, but it will go into 16. So 2 will go into 16 8 times. 8 times 2 is 16. 16 minus 16 zeroes out. That's what I wanted. Bring down the next number, 4. 2 will go into 4 2 times. 2 times 2 is 4. The difference between 4 and 4 is 0. Bring down the 0, the next term. Well, 2 won't go into 0. It'll go 0 times. So 0 times 2 is 0. So it works out evenly. So when I divide 1,640 by 2, it's going to give me 820. And what that means is that if I take this sequence and I add up all 40 terms of it, the total is going to be 820.